To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Right, my dear children. So, in the previous chapter, we have answered the first and second question related to the structured part. Now, within this chapter, we'll be answering third and fourth questions. So, these third and fourth questions related to chemistry and physics part. So, within the previous chapter, we discussed about the biosphere lesson question and we discussed one question related to the biology lesson parts. Then, my dear children, within here 3 and 4 questions reflects about the chemistry parts and the physics parts. So, the question number 3, actually, the third question is reflecting about the chemistry parts related to the grade 10 and 11. Okay, so here there is a certain structure, dot cross structure given. From that, you have to answer the questions in part A. In part B, my dear children, certain part of the periodic table is given. Then there are graphs shown by these two like this, electronegativity and the ionization energy. So from these you have to answer the questions given. Okay, right, now let's head on to see the first and foremost question of the chemistry question given here. Right, figures 1 and 2 indicate Lewis dot and cross structures of two molecules formed by the atoms belonging to the three elements X, Y and Z. X, Y and Z are not their standard symbols. The atomic numbers of X, Y and are less than 10. The atomic number of Z is higher than 10 and lower than 20. So X and Y are between are less than 10, my dear children, but Z is between 10 and 20. Okay, so let's see the questions. The atomic number of X is in here. X has created 1, 2, 3, 4 bonds. X has created 4 bonds. So that means within the outermost energy level, within the valence energy level, my dear children, there should be 4 electrons in X. Okay, in X there should be 4 electrons. So that means, my dear children, when you take the element X must be in the 4th group. So 4th group, in order to be in the 4th group, less than 10, right? The number of protons or the atomic number should be less than 10. The question itself mentioning that X and Y, the atomic numbers are less than 10 in X and Y. So last energy level there should be 4 electrons, atomic number should be less than 10. That means, my dear children, this is definitely carbon, right? Definitely carbon. That's the only element located within the 4th group. So it's the only one that has 4 electrons in the last outermost energy level, which is less than 10 in atomic number. So carbon is the answer. But however, the atomic number of X is the one which is being asked. So carbon is in the 6th place. Hydrogen, helium, lithium, beryllium, boron, carbon. So if it is in the 6th place, then the atomic number of carbon is 6. So carbon, 6 is the atomic number. Period to which X belongs in the periodic table. So period which X belongs to the periodic table. So you have to get the period. To get the period, X is equal to 2, 4, right? So period number is given by using the energy levels which used to write down the, right, the energy levels which used to write down the electronic configuration. That's equal to period. Group is equal to electrons in the last energy level. So we have used 1, 2 energy levels. That means, my dear children, second period. Second period is the answer. The period to which X belongs in the periodic table is second period. Then the next question. The group to which Z belongs in the periodic table. The group which Z belongs. Z. So the atomic number of Z is between 10 and 20. No? So Z is in here. You can see that clearly Y is having only 1 electron in the last energy level. So Z has, that means 1, 2, 3, 4, 5, 6, 7, 7, right? Z has 7 electrons in the last energy level. So 7 electrons in the last energy level means it should belongs to the 7th period, right? 7th group, right? It should belong to the 7th group, not the 7th period. There's no 7th period in our periodic table, no. So it belongs to the 7th group in our periodic table. So 7th group, the atomic number should be greater than 10 but less than 20. That means it should be 17. It's like this, no? 2, 8, 7. So the group which Z belongs in the periodic table is the 7th group, my dear children, right? Asking about the group. So 7th group should be the answer. So when writing the answer, remember, we have to use Roman numbers like this. 7th group. Z belongs to the 7th group, right? The molecular formula of the compound formed by the combination of Z and X and Z. So X is carbon, no. Z is over here, right? Z is over here. Z is chlorine. So chlorine, carbon. Chlorine and carbon, Cl. Carbon valency 4, chlorine valency 1, as it is in the 7th group. You interchange these two, CCl4. But remember, the question is asking about the molecular formula of the compound formed by the combination of X and Z. So remember, you need to write down the answers by using the symbols given over here. So it should be X, then Z, then 4, right? After writing down this thing, you can, if you want, you can include CCl4, no problem. XZ4 is the answer. Next one, the type of chemical bonds existing between the atoms of X and Y. When you take the atoms of X and Y, the type of chemical bonds. So carbon and chlorine both are nonmetals, my dear children. Therefore, the bond type should be covalent bonds. Covalent bonds. Covalent bonds are the ones which we can observe within non-metallic substances. Usually nonmetals are the ones that create covalent bonds. So covalent bonds is the answer. Next one, the type of chemical bonds existing between the atoms of Z and Y. Z and Y. So Z and Y, my dear children, right? Here, once again, those things are covalent because Z, we know that it is chlorine, and Y, here, hydrogen, right? So hydrogen and chlorine, those things are also covalent. But the specialty here is that you know that when you take the electronegativity of chlorine and hydrogen, they have a huge gap or difference, which means chlorine is going to attract the bonded electrons towards its side, right, at a greater rate than hydrogen. So if at a greater rate the bonded electrons are getting attracted towards chlorine, chlorine can receive a certain small bit of a negative charge, while a positive charge is getting obtained by hydrogen, which means within the molecule plus and minus charges are getting separated. That means, my dear children, you can clearly write down the answer that HCl molecule, that's a polar covalent molecule, okay, polar covalent molecule. So we can write Z and Y, polar covalent bonds. Polar covalent bonds, right? For the top one, the type of chemical bonds existing between the atoms of X and Y, right? X and Y bonds. So for that one, my dear children, for that one also, you can, if you want, include like this, non-polar covalent compounds. Actually, that's much better. Non-polar, right? That's a much better answer, my dear children, because you know that both of these substances are covalent compounds. No, that's why even we can use these dot and cross structures to show the arrangement of their bonds. So because of that, we need to write down the most appropriate answer. Actually, these things are asking about the bond nature, no? So just by writing down covalent bonds will not enough, right? So marks will not be given. So when I'm giving out the marks, I'll let you know what is the thing given in the marking scheme for that answer, right? So it's quite important to write down the most appropriate and the most correct answer. So all of these things are showing covalent structures. That is actually why we can represent these things like this, because these things are covalent compounds. Covalent compounds can only be drawn, right, or else these are the ones which can only be drawn by using the dot and cross diagrams, Lewis structures, and dot cross diagrams, right, dot diagrams. So therefore, my dear children, when you are asking about the bond types, so mention polar or non-polar nature. Okay, that's a good answer, right? So the type of chemical bonds existing between the atoms of X and Y, this is a non-polar molecule, my dear children, because when you take the central atom, the electronic distribution is similar or equal, or it is symmetrical. But however, over there, as hydrogen is less electronegative, chlorine is going to pull the bonded electrons at a higher rate, or higher, at a higher rate. So therefore, what will happen? The electronic distribution among the atoms, or the electronic distribution among the molecule, is going to be differ. So because of that, it will receive a certain negative charge. The chlorine will receive a certain negative charge, while the hydrogen is going to take a positive charge. Because of that, it becomes a polar covalent compound, right? A polar covalent compound. So therefore, between Z and Y, we can observe polar covalent bonds, and between X and Y, we can observe non-polar covalent bonds, right? Next one. The chemical formula of element Z when it exists in free state. Z is chlorine, no? So it is available as a gas, a diatomic gas like Z2. Diatomic gas as Z2. If you want, you can write within brackets Cl2, no problem. For this one also, you can write XZ4, CCl4. Okay, CCl4 within brackets. But however, these things are important. Remember to represent these two. Right. Then the part B. The elements in the third period of the periodic table are given below with their atomic numbers. Okay. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. So 11, 12 to 18. Then the graphs 1 and 2 below shows marks as dot in the position belong to the element silicon. Okay. So in the graphs 1 and 2 below, mark the dot or the coordinate to the position belong to the element silicon. So you have to mark silicon over here. Okay. As a dot within these tables. So for the first table shows the electronegativity, my dear children. Electronegativity, the variation of electronegativity is quite simple. When moving from left to right, gradually the electronegativity increases. Okay. Electronegativity means ability of attracting electrons in simple terms. Okay. Ability of attracting an electron in simple terms. But if you elaborate even more, the ability of attracting bonded electrons when they are bonded with a covalent bond. That's what do you mean by the electronegativity. But in simple, we can say that the ability of attracting electrons. So ability of attracting electrons will get increased gradually when moving from left to right in a period of periodic table. So in simple, here we can represent silicon like this. This is silicon. number 14. Right? Then in here, once again the same thing can be observed. When moving from left to right, the ionization energy is going to increase. Ionization means it's the ability of removing electrons by giving a certain energy. We know that we have to provide some amount of energy to remove an electron from the atom, because the nucleus of the atom is positively charged and the electrons are negatively charged. And because of that, right, because of that, protons and electrons are having a certain attraction. So in order to remove an electron, we have to provide external energy. So by providing external energy, removal of an electron is referred to as electronegativity. The energy that should be provided for that process is the electronegativity, right? So when moving from left to right in a period, my dear children, gradually the energy that we need to provide to remove an electron, that means the ionization energy, is gradually increasing, right? That's keep getting increasing from time to time. That means when moving from left to right in a period. So, but there is a certain fluctuation in the second to third and fifth to sixth. However, usually it keep getting increased from group number 1 to group number 8. So here aluminium is in third group. Now the 14th one, which is in the fourth group, silicon, it's very important to include or to show the ionization energy. You know that it is in the fourth group, so the ionization energy should definitely go beyond magnesium. So it should definitely be greater than magnesium. So you need, when you're marking this thing, definitely include like greater than like this, right? That means this is the magnesium level now. So it should be above the level of magnesium for sure, because it's keep getting increasing when moving from left to right, other than the groups 2 to 3, then 5 to 6. So those things have not been asked in here now. So always remember, the elements in the fourth group definitely has higher electronegativity and higher ionization energy compared to the other groups. So it should go beyond magnesium. So this is silicon. Right. Then the next question. Of the elements in the third period, select the element fitting each of the following statement and write its chemical symbol in the blank. Element forming a chloride with M2 ions. M2 means M plus 2 ions, right? So M2 ions means 2. M2 ions, that means 2 plus ions. So it should be 2 plus ions. So M2 plus ions, 2 plus ions are getting created with the help of, like here, magnesium. Actually, magnesium is the one which is observed over here, which have the ability to release 2 electrons. So M2 ions or M2 plus ions is observed within magnesium. Element forming an amphoteric oxide. Very simple, my dear children. Amphoteric oxide means it should show both acidic and basic features. That's very simple. The one and only aluminium. Aluminium is the one which shows amphoteric features, right? So aluminium oxide, it shows both acidic and basic features. Next one. Element existing as a monoatomic gas, right? Monoatomic gas. So monoatomic gas means what? So when you take the graph 1, right, and graph 2, so monoatomic, mono means 1. Mono means 1. Atomic means 1 atom. So one atomic gas. So 1 and 2 tables showing about sodium, magnesium, aluminium, then sodium, magnesium, aluminium, those things. But however, when you're looking at this one, the 18th, argon. Argon is an inactive gas. It's because the last energy level of argon is completely filled with electrons. Okay, it's completely filled with electrons. That means, my dear children, it is a noble gas. So noble gas are always found as element elements in our nature. That means it is a monoatomic gas, right? So if it is a diatomic gas, then chlorine is correct. So asking about a monoatomic gas, it should be argon. Right, my dear children. Then let's head on to see the next question. Which element in the third period reacts fast with cold water? So which element in the third period react fast with cold water? So there is only one element in our periodic table in our O-level syllabus that we are going to learn about, right? Which is the one which is going to react with cold water, my dear children. In our syllabus, we are learning about only that thing, only that particular element. So that element is sodium. So the one and only element that reacts fast with cold water is sodium. Next one. How do you confirm that a basic solution is formed after the above reaction? So sodium is going to react with cold water to produce sodium hydroxide. It's a good base. So to identify that one, we can add phenolphthalein, right? So by adding phenolphthalein. So by adding phenolphthalein powder, we can identify, right? Into the solution. Within brackets, we can include like this. Colorless will turn into pink color, right? Right. So colorless powder will turn into what? Pink color. So by adding phenolphthalein into the base into the solution, phenolphthalein powder. So by adding phenolphthalein powder into the solution, we can clearly get the observation related to the basic solution, my dear children. Because you know that phenolphthalein is giving out a pink color, right? It is giving out a pink color from the colorless nature, right? If there is a base. Or else for this one, my dear children, we can use what? We can use red litmus, right? By adding red litmus into this solution, if it is getting turned into blue, that means the basic color, right? Base color. By that way also, we can get the same answer, or by that way also, we can get the same observation. So if red litmus is getting turned into blue color, then we can state that it's a basic solution. Okay, right. Next one. Given below is an incomplete chemical equation for the reaction between magnesium metal and steam. Fill in the blanks in it. Magnesium solid, H2O. If it is in the steam state, then this should be gas, my dear children. So a solid is getting created, releasing hydrogen gas. So magnesium is going to react with water, my dear children, right? Magnesium is going to react with water or steam to create, if it is right, if it is in the gaseous state, that means if it is in the steam, right, then the product which is getting created is oxide, the metal oxide or magnesium oxide. So here magnesium oxide is getting created and hydrogen gas is released out. So let's check whether it is balanced or not. Magnesium 1, okay. Oxygen 1, okay. Hydrogen 2, okay. So it is balanced. Right then. So my dear children, we have answered all the questions related to the, right? We have answered. So my dear children, we have answered all the questions related to the third question in your 2022 O-level paper. So now we go for the answers related to the question number 4, Then after that, my dear children, we'll give out the marks for the correct responses according to the marking scheme. Okay, so let's head on to see the fourth question then. Question number 4. So question number 4 is totally related with the physics lesson parts. Okay, so here within the first part of the question, there's a certain rod related with certain forces. So you have to answer the questions related to that one by using the diagram given, right? Then in here, my dear children, there's a spring and there's a metal block. Then you have to answer the questions regarding these things, right? It's mainly focusing about the frictional force and the energy conversion, about the energy like kinetic and potential and so on, right? Okay, so this is the final question in our structured essay part, my dear children. So within the structured essay part, my dear children, there are 4 questions like I said. So this is the final, the physics question. Now let's answer the question then. So the figure indicate how uniform rod AB, whose midpoint is C, is suspended in the ceiling by 2 strings tied to its 2 end and kept in the equilibrium. So it is under equilibrium. So we know that if it is under equilibrium, my dear children, the forces which are acting downward should equal to the forces which are acting upward. That is why it is in the equilibrium state, right? If one particular direction has greater forces, right, that means when you take in magnitude, if the forces are somewhat greater, then for that side or for that direction, the object will move. If these things are in balanced state, then my dear children, you know that, definitely you know that there is no any issues with that. So if it is in the balanced state, then the forces should be in equilibrium. That means forces acting upside should equal to the forces acting downside. Okay, right. So using arrowheads, mark the following forces in the figure. The tensions T1 and T2 exerted by the 2 strings on the rod. Weight of the rod W. So tensions are acting upward like this, T1, T2. Then weight should come like this, W, the forces acting on the rods. So these are the forces which is acting on the diagram, right? So this is important, my dear children. When you are marking tensions, don't mark it like this, right? Don't mark it like this. Some may mark it like this. If it is marking like this, then this is totally incorrect. Sometimes you will mark the weight like this. You will mark weight like this. Then it is also incorrect because these forces are not being suspended on our environment. Those forces are acting on the materials. Like the tension is acting on this material, the rope. The weight is acting on the material, which the rod. Okay. So don't use these kinds of things. Okay, you have to include those things within the material itself. Otherwise, your answer will be wrong for sure. Okay, right then. So remember that it's important to mark these things within the, right, like this within the diagram. Next one. Right, so we have marked tensions and the weight. Okay, next one. What is the relationship existing between T1 and T2? So, relationship between T1 and T2. So, when you take the relationship between T1 and T2, so when you take T1 and T2, my dear children, usually, but however, remember, in order to be like this, the lengths of these materials or the ropes should be equal to each other and they should be made up of the same material. That's very important, right? However, in our syllabus, my dear children, I mean like in our O levels, we'll be receiving those kinds of ones. So always, if the ropes are made up with the same material and if the length of the ropes are equal, right, according to the diagram which is given here, definitely the two tensions are equal to each other. So we can write T1 is equal to T2. The two tensions exerted by the ropes are equal, right? Next one. Write by an equation the relationship among T1, T2 and W. Very simple, my dear children. When I was started the question, I told you that if it is in the equilibrium state, the forces which act in upward should equal to the forces which act in downward. So, we can write the answer T1 plus T2 is equal to W. The relationship among T1, T2 and W. Okay? Right. If the mass of the above rod is 200 grams, what is the value of W in newtons? So, you know that W is equal to mg. W equal mg. So, weight is equal to mass multiplication the gravitational acceleration. Mass is given in grams. So, substitute with the formula, but remember we have to put it in kilograms. Then G is 10. Then 2 zeros to 2 zeros are cancelled. Again 0 to 0 is getting cancelled. So answer is 2 Newtons. 2 Newtons. Next one. Indicate the values for T1 and T2 in Newtons. So previously we wrote that the two forces are equal to each other. Two tensions are equal to each other. Then the weight of the rod is equal to 2 Newton. It's equal to 2 Newton. Weight of the rod is equal to 2 Newton. That means, my dear children, at least one of these tensions should be equal to 1 Newton each. Otherwise, the rod will break down if not. So, if it is in the equilibrium state, which means when you take the mass of the rod, when you take the weight of the rod, it is 2 Newton. No? So, when you take two tensions, so the tension should be able to bear this weight. So, when you take one tension, it should be equal to 1 Newton each. So, here 1 Newton, here also 1 Newton. Right then. So, we have answered the first part successfully. Now, let's go for the second part then. Figure 1 below illustrates a helical spring connected to an immovable support on a table. The other end of the spring is in contact with a block of wood. Figure 2 below shows how the spring is compressed by applying a horizontal force P on the block of wood. Assume that there is no friction between the block of wood and the surface of the table. So, we need to assume that there is no friction on the block of wood and the table. So, there is a spring like this. So, we compress the spring by applying a force P. Then we release it. Okay. Now, let's see the questions. Name the form of energy stored in the compressed spring. If it is getting compressed, then this is elastic potential energy. It is a potential energy, but especially this kind of potential energy is referred to as elastic potential energy, my dear children. Right? Elastic potential energy. This is the answer. Next one. To what form of energy will the form of energy stated in first one above be transformed when the force P is removed? So, when I am going to remove the force applied, the potential energy stored within the spring, right, will get converted suddenly into kinetic energy. That's why the block of wood will move forward. So, here the energy transformation is, my dear children, from potential energy to kinetic energy. So, kinetic energy is the one. Can write to kinetic energy. Right, to kinetic energy. Next one. If the amount of energy stored in the compressed spring is 16 joules and the mass of the block of wood is 0.5 kilograms, calculate the initial velocity of the block of wood. Initial velocity. So, here the energy in the spring is given. That means that energy is getting converted into kinetic energy. Right. So, we can apply kinetic energy formula equal half mv squared, half into 0.5 into v squared is equal to 16 then. Right, now we can do the multiplication first by 2 to remove this 2. 2 to 2 is getting cancelled. So here 32 is equal to 0.5 v squared. Divide both sides by 0.5. 0.5 to 0.5 is getting cancelled. So here v squared is equal to 32 over 0.5. Now you can multiply both sides by 10 to remove that decimal point. So here 320 division 5. It is equal to 64 then. V squared. So I'll take the slide somewhat up. So v squared is equal to 64. Now take the square root. V is equal to 64 square root is equal to 8 ms minus 1. 8 is the answer. So in here, my dear children, to make the calculation somewhat easy, you can do it like this if you want. 32 division 0.5, you can write it like this, 32 division 0.5. 32 multiplication 0.5 means, my dear children, I'll remove the multiplication. 0.5 means 5 over 10, that means half. So 32 multiplication 10 division 5. So here 1, here 2, 2 times 32. Once again, you can get the answer as 64. Okay, I'll mention this thing as a bracket, okay, just to make the simplification somewhat easier. Right. So our answer is 8 ms minus 1. This is the answer. You apply with the formula half mv squared. That's how to find out the kinetic energy possessed by an object. So the force, because of the force P, energy is getting stored within the spring. So that energy is given 16 joules. Then mass of the wooden block is given 0.5 kilograms. Then we can calculate the velocity by using the half mv squared formula. Right? Okay, then the next question. State the nature of motion of the block of wood along the table after it is released from the spring. State the nature of the motion of block of wood along the table after it is released from the spring. Now, we assume that there is no friction between the table and the block of wood. So therefore, if there is no friction, because of the application of force, it should move in constant velocity or uniform velocity, right? So according to Newton's first law, can you remember? Until an unbalanced force applied on an object, the object is moving in constant velocity in a straight path, or else it is in stationary position, right? So now because of application of the force, the object would tend to move, no? So this movement is in uniform velocity, okay? So our answer should be uniform velocity. Right, then next one, the final one. If there was a constant friction between the surface of the table and the block of wood, and if the table had a considerable length, draw the velocity time graph for the expected motion of the block of wood after it has been released from the spring. Very simple, my dear children. If there is frictional force, then gradually the speed is going to reduce, right, because of the friction. So if the speed is getting reduced or the velocity is getting reduced, we can draw the line like this. Without any trouble. So now we can name the axis as velocity. This is the time. Right, my dear children. So we have successfully answered the questions related to the physics and chemistry part in the structured paper of 2022 O-level paper. Now let's give out the correct marks for the correct responses. Okay, so I'm going to take the marking scheme right now. So after that, we'll mark out the questions, the correct responses. Okay, right, my students. So I have the my marking scheme with me right now. So now let's give out the marks for these correct responses. Right. So for writing down the atomic number, 1 mark. Then for mentioning the period, 1 mark. Then for mentioning the group, 1 mark. Then for writing down the correct answer, actually they have given marks for both of these responses. So either of these two, you will be getting 1 mark. Then for mentioning covalent bonds, actually within the paper, my dear children, within the marking scheme, they have mentioned covalent bonds for both the answers. For these answers also, marks are also given. So there is no problem in it. So here, 1 mark. So here, 1 mark for the non-polar covalent bond thing, right? 1 mark. Then in here, for the type of chemical bonds, in the second one, polar covalent bonds, again 1 mark. If you have mentioned only covalent bond, then also you will be given marks, no issues at all. Okay, they have mentioned it. Next one. For mentioning the chemical formula Z2 or else Cl2, again 1 mark. Right. Next one. For placing silicon correctly, right, in here 1 mark. Then in here again 1 mark. And they have specifically mentioned that silicon must be marked above magnesium. So can you remember, like I said, silicon must be definitely marked above magnesium. Okay, right. Next one. So for writing magnesium, 2 ions, 2 plus ions, 1 mark. For aluminium, 1 mark. For argon, again 1 mark. Right. The next one, for writing sodium, it's the one which is going to react very fast with cold water, 1 mark. To identify, right, turning phenolphthalein into pink color or else red litmus, you can use any of, right. So however, you are given with only 1 mark for that one, for any of the methods, right. Next one. In here, my dear children, for mentioning the physical state, right, and for writing down the answer, you have given with 1 mark, right. So it is mentioned in that physical state is compulsory. Okay, so these are the marks for the correct responses in third question. Now let's head on to see the fourth one. So fourth question. So for marking the forces on the strings correctly, right, they have given for the marking T1 and T2 using the words 1 mark, and for marking using an arrow downward, again 1 mark. So here they have provided 2 marks, right. Then next one. Next one, my dear children, for writing down the relationship between T1 and T2, 1 mark, right. Then for writing down this relationship, again 1 mark. Then here, once again 1 mark each for these calculations. 1 mark for 2 Newton, then 1 mark for 1 Newton, 1 mark again for 1 Newton. Right. Okay. Then for the next one, the elastic potential energy, 1 mark For potential energy also they have given marks. So for the next one, the kinetic energy. For the kinetic energy, 1 mark. Right? For the kinetic energy, 1 mark. Then for the calculation, right, 2 marks are given if they have if the units are not there. If units are not marked, then my dear children, they have given only 1 mark, right? So 1 mark for the substitution over here. In here for the substitution 1 mark, and for the answer 1 mark. So altogether you will be receiving 2 marks. If units are not there, then you will not be receiving marks for the answer. Okay, you will be giving only 1 mark for the substitution part. That's it. So 2 marks for that one. The next one, for the uniform velocity or uniform speed or constant speed, 1 mark. Then for drawing these axes correctly, right, by you need to represent, or else you need to name these two axes correctly, velocity and time. Then for that you have given 1 mark. Then again 1 mark for the plotting, right? For these two again 1 mark given. So altogether you have given me 2 marks for this question, right? So that's why I told you that we need to mark the axes when you are representing a graph, right? So my dear children, we have answered all the questions in our part A of the second paper, the structured essay 1, right? So I hope that you got a good idea about answering the questions and the way of giving out the marks for the correct responses. So my dear children, in our next chapter, we'll be discussing about the essay type questions, the second part related to part B in our second paper, right? So over there are 5 essay type questions starting from 5 to 9, 5, 6, 7, 8, 9 questions. So those things will be discussed in our next chapter onwards, my dear children, right? So that would be our final paper, right? So there are 3 papers, right? Actually there are 2 papers, but however there are 3 structures in the paper. So that would be our third and the final structure, the essay type 1. So in our next chapters, we'll discuss the further things related to this, the paper discussion, my dear children, right? In our next chapter, then in our next chapters, then we'll discuss the essay type questions. Okay, right? So stay with me till the end of the discussion, my dear children. So by that way, you can get a good knowledge about the question paper in our 2022 O-level, right? So I hope that you guys will stay with me till the end of the discussion, right? Then I hope to meet you with the next chapter to discuss the other questions then.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.